These are the video notes for the second fundamental theorem of calculus 2. So second go round at the second fundamental theorem of calculus. So we start here with A, right where we left off. And then when we take the derivative of the integral, when the upper bound is x, then the value of that is cosine of x. Don't like that color. Pick a different color. When we take the derivative of the integral, when the lower bound is x, right, so then the upper bound would be the constant, the lower bound would be the variable. This would then be minus cosine of x. Here, if the lower bound is a constant and the upper bound is a constant, then we get 0 minus 0 or 0. And D, we start to get a little bit interesting here. So first off, let's just remind ourselves that this here, the integral, looks like this, right? So it is the sine of t with a lower bound of 7 and an upper bound of x squared. And then we're going to evaluate that, which will give us the sine of x squared minus the sine of 7. And then we are going to take the derivative of that. And when we take the derivative of that, dx, what we end up with is the derivative of sine x squared, which is going to be cosine x squared, but then we need to take the derivative of the inside function, which is going to be the 2x. Right. So what ends up happening here is the same thing as we were doing yesterday. We end up with the derivative of the integral being the function itself, using the variable that is the upper bound as the variable, but because the variable that is the upper bound is not simply an x, and in this case it's x squared, the chain rule requires us to do the derivative of the upper bound, which is what this is. All right, so let's try e. Look at what happens with e. Again, the same thing. The derivative of the lower bound is going to be 0 because the lower bound is a constant, but the derivative of the upper bound is going to be 3x squared. And then we end up with the cosine of x cubed. In the last one here, lower bound is a constant, it'll be 0. Upper bound is the square root of x. So the function is the cosine, and we have the square root of x is the input to the cosine function. And then we need to take the derivative of the square root function, which is the square root of x function, which is this. So then we get 1 over 2 root x. Right. And then here, example 2, same exact pattern. We don't need to know what the integral of the natural log is. We just know that when we take the integral and then turn around and take the derivative, lower bound is going to end up being a constant, which would be 0. Upper bound is going to be the natural log when we take the derivative, we'll get back to the natural log, and it'll be the natural log of 3x squared. So we have the natural log of 3x, actually this is 3x to the 6th. Put that in parentheses. And then the chain rule requires us to take the derivative of this inside function, so we would have 18x to the 5th. So then in general, the second fundamental theorem of calculus with the chain rule, right, so that's what we're adding on today, right, this idea of with the chain rule, is going to end up being, right, so we'll start, so if you take the derivative of an integral where the lower bound is a constant, the upper bound is a variable, and in this case we're going to have the upper bound be a function, and we're taking the integral of a function f of t with respect to t. So then the integral here, the antiderivative, the parent function, would be capital F of t. We would substitute, or substitute in the upper bound, so it'd be capital F of t of, capital F of g of x minus capital F of a, and then we take the derivative of that. All right, so just as a little note up here to remind us of where we are, so the integral here ends up being capital F of g of x minus capital F of a, and then we want to take the derivative of that. So this is a constant, becomes 0, and we just end up taking the derivative of this. So it's the derivative of the outside function, and the derivative of the outside function is, the child function is f function with the input g of x, and then times the derivative of the inside function, which is g prime of x. Right? So here we have the second fundamental theorem of calculus using the chain rule. Right? So let's try a few examples here. So I would suggest that you pause the video and then you try A, B, C, and D, and then when you've done pausing the video, you come back and check your answers. And here are the answers for you. Check to see how you did. And I'm going to move on to example 4. So in example 4, the function we're interested in is the integral of the function 2t plus 5 with respect to t from the lower bound of 1, a constant, up to the upper bound of x squared. And we want to find f of 2, f prime of 2, and f double prime of 2. So f of 2 is then equal to the integral. Lower bound is 1. The upper bound is going to be 2 squared, or 4, of 2t plus 5 dt, which is t squared plus 5t from 1 to 4, which is equal to, plugging in 4, we get 16 plus 20. Plugging in the lower bound, we get 1 plus 5. So that's 36 minus 6, or 30. Right, so the first answer is 30. Now to find f prime of 2, we got to find f prime. So f prime of x is simply equal to so we're going to rewrite the integral function using the upper bound, which is 2x squared plus 5, and then we're going to take the derivative of the interior function, the x squared. So then f prime of x is equal to 2x times the quantity 2x squared plus 5. And then, well, actually we can, let's write this, simplify this out, or expand it, if you will. We would get 4x cubed plus 10x, and then that would mean that f prime of 2 would be equal to 4 times 2 cubed plus 10 times 2, which is going to end up equaling 52. So the second answer is 52. And then for the last question, we need to find f double prime of x, and we're just going to take f prime of x here. F double prime of x is 12x squared plus 10, and then I plug into that the input of 2, and I'm going to get 12 times 2 squared plus 10, which is 58. 58. And then I'm done with side 1. And then what you'll notice here is that in the packet that you have, side 2 should look kind of familiar. Side 2 should look kind of familiar. We've done this. This is actually the second page in your packet. So we are now done with the notes